Question 7e, page 50 of the textbook FP2. We're invited to sketch the locus of z when arg z minus arg of z minus 2 minus root 3 equals pi over 3. If we put it in this form, then we can just read off where the point 2 minus root 3 is from where the half line will be drawn. That's down there, and the one for arg z is up here. Following the usual procedure, if we just take arg z is equal to pi over 2, then we have to take away from that pi over 6 in order to get pi over 3. So that's our provisional idea. But the moment we look at the diagram, we can see that the half line arg z minus 2 minus 3i goes off in that direction, and arg of z equals pi over 2 goes off in that direction. So they're clearly never going to meet. So we're going to need the negative where arg z is minus pi over 2, and where the half line from A has been rotated 5 pi over 6, so that's minus 5 pi over 6, minus pi minus minus 5 pi over 6, and that does indeed give us pi over 3. So that is a point on the circumference of this circle, for sure. Because this angle here is 60, and the locus we want is going to be coming around from here all the way round to there and further on round. Now, if we want to find the Cartesian equation of this locus, then we're going to be looking for the Cartesian equation of the circle, and then we'll limit it in some way. So the first thing is we've got to work with our knowledge that if you have a circle and two chords of that circle, then their perpendicular bisectors will meet at the center of the circle. Well, I've got a chord here OB, so if I can bisect that perpendicularly, and a chord OA and bisect that perpendicularly, they will meet at the center of the circle. At that point, it's easy enough to use some Pythagoras to find the radius of that circle. So let's proceed along these lines. Let's find the point B. Clearly the x-coordinate is 0, so now we're going to be looking at the y minus y1 equals mx minus x1. And if we look here, we've got a 30, 60, 90 triangle, and so the tangent is the gradient. The tangent of that triangle is the gradient of the line, let's call it L, coming down here. So the equation of L is going to be 1 over root 3. Y minus negative 3 equals 1 over root 3 x minus 2. And that's perfectly satisfactory. Y plus 3 is equal to 1 over root 3 x minus 2 over root 3. And we can see that when x is 0 on the y-axis, then y is going to be equal to minus 3 minus 2 over root 3. Now the perpendicular bisector obviously goes through half of that, so if the point, we're going to want this line, and that line will be y is equal to half of this. So the perpendicular bisector of OB is y equals minus a half of 3 plus 2 over root 3. So we've got 1. Well, let's construct that and draw it in, see what we get. This does only take a moment. So there's our perpendicular bisector. And while we're at it, we might as well do the perpendicular bisector of OA as well. So that's going to be coming down there and there. Oh, and it looks as though where our two arcs intersect is almost exactly where the two perpendicular bisectors of the chords meet. So that must be the centre of the circle there. Let's call that C. And it's pretty clear that it's going to be round about 2 steps down and much less than 1 step across. So we've got an idea what C is going to be anyway. Well, we know the y-coordinate because the y-coordinate is going to be that. So now let's see if we can find the x-coordinate. What's the equation of this line going to be? Well, that point is 1 minus 3 over 2. Just taking the average of 0 and 2 and 0 and minus 3. And what's its gradient going to be? Well, that's 3 and that's 2. So the gradient of this line is minus 3 over 2. The gradient of this line, which we'll call m, is going to be 2 over 3. So we can say m is such that y minus 3 over 2 is equal to 2/3 of x minus 1. Now these two lines are intersecting, so we're going to have a point where both y is minus a half of that expression and y is equal to, well, y will be governed by this equation as well. So we can simply substitute that into there. And we're going to get minus a half, 3 plus 2 over root 3, plus 3 over 2 is equal to 2/3 of x minus 1. And I can see I've got a 3 over 2 there and a minus 3 over 2 there, so I'm left with 2/3, 2 over root 3. And from this side I'm going to have 2/3 of 1 coming in, so that should be a minus, shouldn't it? It's minus 2 over root 3 times that half. So, and then on the other side I'm going to have a minus 2/3, so that's going to be plus a 2/3. That's what x is going to be equal to. So x is going to be equal to 2/3 minus 1 over root 3. And that turns out to be 0.089, just as we thought. So it's less than 1/10 of that unit there, which is just what it looks like. So now we've found the point C. So C is the point 2 over 3 minus 1 over root 3, and the y-coordinate is going to be minus a half of 3 plus 2 over root 3. Perhaps we can simplify that a little bit. 2 over 3 minus 1 over root 3, and then minus 3 over 2 minus 1 over root 3. Well, from here, if we want to know the radius of this circle, or rather, if we want to know r squared, if we square that, and we square that and add them together, and we do get 13 over 6. 13 over 6. So now we can give this equation as the equation of a circle, which is the equation of a locus, x minus 2 over 3 minus 1 over root 3, all squared, plus y minus 3 over 2 minus 1 over root 3, all squared, equals 13 over 6. And we can limit that circle to give us this locus, which I shall now draw in. Here it is, and it very satisfactorily goes through the point B, close enough, and the point O, and so this is the bit of the locus that we want.